Hi, I'm Quinn. I'm from St. Louis, Missouri, and today we're going to talk about quantum computers. I know that looks like a normal computer, but it's fine. First, we got to clear up a few things about quantum physics. First, particle wave duality, then quantum entanglement and superposition. Now, to explain particle wave duality, we must imagine it as an electron as a wave and a particle. In doing this, when you square the amplitude of the wave function, you get a probability distribution of where the electron could be. High at the high parts and low at the low parts. Here's something called the double slit experiment to imagine this. If we fire, say, paintballs at a wall with the two slits, the paint splats will appear in two stripes the size of the slits. But if we use the same apparatus to fire electrons, then they will appear in a bunch of little stripy bits, and we're like, what? But if we analyze it further, we see that where the electron marks appear is where their waves overlap, further proving that although they appear on the wall as a particle, they behave as a wave sometimes, and this is particle wave duality. Now there can be many wave functions, including this one. This has two equal-sized humps showing these two waves can be combined to make a superposition of equal probabilities. Finally, for entanglement, we can imagine two electron waves meet and they're all like, cool, bam, they're entangled. And no matter how far apart they are, even across the world, if we know information about one, we know the opposite of the other. Now, how the heck do we make a computer with this? Well, classical computers run on bits of info that have a value of 1 or 0, but quantum computers run on qubits that can be 1 or 0 or a combination of both. This is superposition. This allows for faster processing of information, as 4 classical bits can have 2 to the power of 4 combinations of 1s and 0s, but qubits can be in all of these combinations at the same time. Crazy, right? Not to mention entanglement, which would allow for faster processing where bits would need to be analyzed one by one. Entangled qubits could find out information about the others much quicker. All this leads to endless possibilities with quantum computers. First, we can now simulate quantum physics in newer complex molecules that would revolutionize medicine, not to mention that using quantum encryption would make it nearly impossible to crack important code without guessing every single possible superposition. In summary, quantum computers are pretty cool, and they're definitely going to change the world.